Today we're going to learn how to transform the graph of a parent function. First thing you have to do is recognize the parent function, and looking at our question, should be able to easily see that the parent function is y equals 1 over x, which I put over here on the right side. We should now look at what kind of transformations are occurring. You might notice that the negative sign, we usually do reflections first, and this negative sign over there indicates that you're going to have a reflection about the y-axis. So in words, there'll be a reflection about the y-axis. And then our next transformation will be the x plus 2, which means we're going to be moving the graph 2 units to the left. So we'll write that down. Move 2 units left. And finally, you'll see the plus 1. And that means we're going to be moving the graph up 1 unit. So we'll write that down. And now let's start transforming our graph. I took the liberty of putting the original parent graph down below here, where you see the asterisks. And we're going to label 2 points that we can follow. One is at 1, 1. And one is at negative 1, 1. Our first transformation says let's reflect it about the y-axis. So we will do that. And the easiest way to do it is, first of all, to draw our point 1, 1. If it gets reflected about the y-axis, would end up at negative 1, 1. And our other point, negative 1, 1. Negative 1, I do see a mistake at our original parent function that was at negative 1, negative 1. Don't want to make mistakes. And that point, when it gets reflected about the y-axis, ends up at positive 1, negative 1. And now we could sketch our graph. Make sure it goes through those points, those 2 points. Making sure it never touches the x and y axis, because in this parent function, the x and y axes are asymptotes. Our next step is to move it 2 units to the left. So what we're going to do is, the easiest way to do that is first to move the asymptotes 2 units to the left. In this case, we're talking about the vertical asymptote. And we will simply draw a dotted line through the point negative 2, since the y-axis asymptote has moved over 2 units. And we go there, and now we want to sketch it. Remember, if we're sketching it, we have to see where our original points went. And our point at negative 1, 1, which is right there, if it's moving 2 units to the left, will now be at negative 3, 1. So we'll put it there, negative 3, 1. And our other point, which is at 1, negative 1, moving 2 units to the left, will be at negative 1, negative 1. And now we should be able to sketch our graph, keeping in mind the x-axis is an asymptote, plus this new vertical line is an asymptote through negative 2. And it's something like that. Our last transformation is to move the whole graph up 1 unit. The easiest way to do that is to move the asymptotes over. Up 1 unit. Since the x-axis is an asymptote, we move it up 1. So we'll sketch in our asymptote. And remember, we also still have our asymptote at negative 2. So we will put the asymptote at negative 2. That's still there. And since everything moved up 1 unit, we have to move those 2 points up 1 unit. So our point at negative 3, 1 now moves up to negative 3, 2. And that's right there. And our point at -1, -1 now moves up to -1, 0, which is right there. And now we can sketch our graph going through those points, keeping in mind the two asymptotes. And it'll look something like that. And something like that. So we now know where our 2 points end up. And our 2 points end up at -3, 2. So we'll write -3, 2. And at -1, 0. Those are our points. When we're asked for the domain, we just simply want to see, are there any y values that we cannot have? And you should notice that you cannot have a y value at 1, because that's where the the asymptote is. It goes to the point 1, y equals 1. So actually, I was just doing the range. The domain, it cannot go through the point -2. Notice the vertical asymptote goes through -2. You can't touch that. And therefore, the domain is all real numbers except x is not equal to -2. Once again, that's because the vertical asymptote goes through -2, and you cannot touch, cannot go through or even touch that asymptote. Now the range, which I originally was trying to do, we look for any values any y values you can't have, and you notice you cannot have a y value at 1, because that's where the the asymptote y equals 1 goes through. That's that black asymptote. So once again, it's all real numbers. Except y cannot be equal to 1, and that is our range.